Today we're going to learn how to run benchmarks locally on our system, which can be useful for multiple reasons. On the one hand, some models are just not benchmarked because they're too niche. Maybe you also have your own fine-tuned models that you want to benchmark. And also on the other hand, maybe you want to create your own custom benchmark. So you want to come up with your own sets of tests, exams, whatever that you want to evaluate models on. So what we're going to learn today is how to, on the one hand, host the models with vLLM locally, and on the other hand, how to run the evaluation, how to run the benchmarks against these models. I think this is a very useful skill to have today. So if you like this video and if you get value out of it, let me know by hitting the like button and subscribing. And now let us get right into it. Alright, so we're going to learn how to benchmark models locally on our system. It doesn't have to be locally, you can also do that on a server, but we're going to talk about how we can run benchmarks ourselves. This means benchmarks that we all know, like terminal bench, SWE bench, or human eval and stuff like this, but it can also mean customized benchmarks. So we're going to need a couple of tools today. I'm going to briefly discuss them. These are the tabs that I have opened up here. On the one hand, we need Hugging Face to get the models. You can choose whatever model you want. I'm going to go with very small models here just so we get results quickly. So I'm going to go with something like Qwen 2.5 coder, 0.5 billion parameters, or Qwen 3, 0.6 billion parameters, just to speed this up for the sake of this video. But of course, you can use whatever model you want. You can easily pull them from Hugging Face. In addition to that, we're going to host a model using vLLM. I'm going to do this on my DGX Spark, or Dell Pro Max with GB10 is the correct name. This is the Dell implementation of the DGX Spark. I'm going to run the models there, so I'm going to connect via SSH. It's still local, but for me, it's going to be an SSH connection. I'm going to host the models using vLLM and also using Ollama. We're going to take a look at both. And then we're going to go to the actual harnesses, the actual evaluation frameworks. And here it matters what kind of metric we're targeting, what kind of benchmark we're targeting. The most commonly used one is the LM evaluation harness. This is basically used for most benchmarks. It has a huge list of tasks that we can evaluate against. But for some benchmarks, we also use different tools. For example, for human eval, it's recommended to use Eval Plus. For terminal bench, we use Harbor, which is a different kind of harness that can work with a terminal in a more effective way, I guess. So depending on what kind of benchmark you want to evaluate against, you have to use different frameworks. So we're not going to cover all the frameworks out there because sometimes you have a specific harness for one specific benchmark. We're not going to go through all of those, but we're going to go through those three because terminal bench is a very important one. This is why we're going to take a look at Harbor. Eval Plus is also a very popular choice. We're going to take a look at human eval, and then we're going to take a look at a couple of benchmarks here with LM evaluation harness. And we're also going to create our own very trivial benchmark just so you see how this works as a proof of concept. Now, what's going to be relevant for you in terms of the setup is whether you want to run all of this on a single machine, so you want to host a model and also submit the tasks on the same device, or whether you also want to have a split like me where you connect to a device, my Dell box in this case, where the model is hosted and I submit the tasks here on or from my desktop PC. Depending on the setup you choose, you either run all the commands on the same device or you connect to a device and run some of the commands there and some of the commands on your desktop machine. So in my case, I'm running this on a Dell Pro Max with GB10. So what I'm going to do is I'm going to use SSH to connect into that device. So SSH Dell GB10 is the host name I use here. I'm going to provide my password. And in here now on this device, I'm going to use vLLM to host a model. So to download a model and to also make it available as an API. So what I'm going to do is I'm going to go to documents. I'm going to create a new directory, vLLM hosting, let's call it. I'm going to go vLLM hosting. And here I'm going to create a UV project. Now, you don't have to use UV if you don't want to. You can install vLLM globally, but I'm going to go and say UV init. Then I'm going to say UV venv to initialize your virtual environment, and then UV pip install vLLM torch backend equals auto. And then basically what I have to do is I just have to get the repository from Hugging Face. So I can choose a model like this one here. I just have to copy this part, Qwen 2.5 coder 0.5 billion. And then I just run the command uv run vLLM surf. I provide the repository. And actually in this case, I want to go with the instruct model, which is a different model, but I want to use this one. And then we just need to provide the host. In my case, I'm going to host this on localhost, so 127.0.0.1. If you're hosting this on an actual server, use the private IP address, use something like 0.0.0.0. For localhost purposes, this is fine. I also want to provide a port. I'm going to go with 8000 here. And then important, we want to provide the GPU utilization. So -- GPU memory utilization, and this is a percentage. So you want to provide 0 point something, which is going to be, if it's 0.5, 50% of the VRAM will be allocated. For this model here, we don't need that much. I'm going to go with 0.2, and this is going to host this model now. It's going to download it the first time when you run this. If you don't have it already on your system, I ran this before, so it will not download the model. And then it's going to host this model, and it's going to make it available on localhost port 8000. And again, if you're running all of this on one machine, you do the exact same thing, but just on your desktop PC, for example, or on the server. Now, this device has quite a bit of memory. So if I go into the dashboard, you will see that this has 128 gigabytes total. So taking 20% of that, 23 gigabytes is quite a bit, but it's definitely going to be enough for this model. There you go. So now the server is running, all the endpoints are up, and I can go to NVIDIA Sync, click on vLLM here. This is a port mapping. You don't have to care about this if you're not using the same setup as me. This basically now means that the localhost port 8000 on the machine is also the localhost port 8000 on my desktop PC. So I can go now to my tutorial directory and create a UV project. Let's say no package here. And what I'm going to do here is I'm going to install the first package that I want to take a look at, which is, remember, the one that I mentioned is useful for most of the benchmarks, the LM evaluation harness. And if you go to the installation section here, you can see you can install it in different ways. I'm going to install it with HF for Hugging Face and vLLM for vLLM. So I'm going to say here UV add and then LM underscore eval and then in square brackets HF vLLM. And once everything is installed here, what I can do is I can say UV run, then LM eval ls tasks. So this is going to list all the benchmarks, all the tasks that I can use to evaluate models. So there you go. We have a very, very long list. I'm not going to go through all of this, but these are all tasks that we can use for evaluation. We just need to provide the identifier, and that's it. The one I'm looking for here, I'm going to scroll up, or actually I'm not going to scroll up. Let me grab the result. I'm looking for HellaSwag, which is for common sense reasoning. So the idea is we're asking the model questions, and it has to show that it has common sense, and it has to show that it can complete the sentence in a reasonable way. So yeah, HellaSwag, and we have also the different languages. We're going to target this one for the first evaluation here. How do we actually do that? We also do that here with UV run if you're using UV. Otherwise, you can do LM-eval directly. But here now we're going to run the benchmark. Now, since we're running this locally, I'm going to say -- model local underscore completions. And then we need to provide model args. And the model args are going to have the model identifier and also the host that we're targeting, the endpoint that we're targeting. So I'm going to provide a string here. I'm going to provide this as quotations. Model is going to be equal to, and now I have to copy again the Quen identifier, so the Hugging Face repository. Don't forget that we used -instruct, so that's important. Then comma base URL is going to be the localhost. So http://localhost port 8000. But we need to target the completions endpoint. So version 1 v1 completions. Then we need to specify the tokenizer. In this case, the tokenizer is the same as the model. So it's going to be tokenizer and then -instruct again. The tokenizer backend will be equal to Hugging Face, and tokenized underscore requests will be false. So these are the arguments. We're just defining the model that we're using, the tokenizer and the endpoint. Then we're going to say -- tasks, and here we're going to just provide HellaSwag. And to keep it simple, to not go through the full benchmark, we're going to say -- limit 20. So we're only going to go through the first 20 tasks or examples. So I'm going to run this now, and this should connect to my vLLM endpoint here, which is running on localhost 8000. And I have the port mapping, so it's also running on localhost on this machine. And I see here that I made a typo. It's not local underscore completions, it's local -completions. And I also think that I forgot one more thing, which is to add the API option to the installation of LM eval. So probably it's going to fail again, and I'll have to add this first. There you go. So I'm going to say UV add, again, LM underscore eval, and then I'm going to add API here as an option as well, which is going to install Tenacity, which is needed. And then I can run the command again with local -completions, and this should now work. There you go. You can see that the endpoint is being targeted. We did go through 20 examples, and we got a metric and accuracy metric for this benchmark of 0.3. This is not very good. We also have a standard error. And if I want to run this now on a full benchmark, if I want to evaluate the Qwen 2.5 Coder 0.5 billion instruct model, if I want to evaluate this on the HelloSwag benchmark, this is the command to do it. Without the limit, I'm doing the proper evaluation here. I'm running the full evaluation of this model on this benchmark, and I have a score. So that would already be benchmarking a model. And there you go. Now you can see it goes through all the requests. It won't take forever, but I think it will take probably 10 minutes, 15 minutes here, as you can see, for this to complete. And in the end, we're going to get the same sort of result. It's going to look like this, but we have the full benchmark. And I'm not going to run this because the concept is clear. You just run this command, and in the end, you get the values for the benchmark. So this is how you do that for HelloSwag. If you want to use something else, for example, if you want to use the ARC challenge, which is also a popular benchmark here, you just replace tasks with ARC challenge. And if you don't know the exact identifier, you just do again ls tasks. So lm eval ls tasks, and you will see all the different tasks, and then you can choose one and run the benchmark for this, or run the evaluation for this particular benchmark with this model. And this one is actually not too long, so we can actually wait for this to finish. You can see it should take like 1 or 2 minutes. And there you go, now it's finished. We evaluated this model on the ARC challenge, and we get 0.2312 accuracy. Normalized here, it's 0.2577. Not a very good score, but also a very small and not so capable model. So this is how you can do that. Let's say I want to now run a different model. Let's say I want to do the exact same thing here, but with Qwen 3 0.6 billion parameters. We had this before, this model here. If I want to use that, what do? Of course, I replace everything here, but I also have to start vLLM with a different model. So I have to stop this instance here. I have to repeat the same command. And instead of serving this particular model, I have to serve the other model. And that's basically the principle. I only have to replace the identifier here, so I can copy this, paste it here, host the same thing on localhost, and here I also have to adjust the command. So I go and say that this is actually, the tokenizer is going to be for Qwen 3, and then I also go to the model itself and make sure I use Qwen 3 0.6 billion parameters. So I just have to wait for this to boot up again. There you go. All the routes are active, so I can just run this command again, and now it's going to evaluate the other model. And by the way, ARC is a multiple choice reasoning exam. So we're asking questions with multiple choice answers. And there you go. Now it's finished. We can see that this model, in terms of this particular benchmark, outperforms the previous model. We get 0.31 or 0.339 normalized here compared to the 0.23 and 0.25 of the previous model. But now let's say I'm interested in a benchmark that is not supported by LM Eval. For example, Eval Plus supports the benchmarks Human Eval, or what was the other one? MBPP. These are commonly used benchmarks. I want to use one of those. How can I do that? I don't need to change much. I can keep vLLM running. This doesn't change, but I have to run a different command. And of course, I also have to install additional packages. So I'm going to go here and I'm going to say uv-add Eval Plus. Then everything is installed here. And now I can clear the screen and run uv run eval plus dot evaluate. Then I need to say -- model. No surprise, we need to provide the identifier from Hugging Face. I'm going to copy that again here. This is the model that we're running right now. Then I need to say -- dataset to provide the benchmark. In our case, that's going to be human eval like this. Then I provide -- backend OpenAI, not because we're actually connecting to OpenAI, but because the API definition follows the OpenAI standard. And then also the base URL has to be again HTTP localhost port 8000 v1 completions, or actually for this we don't need to provide completion, just v1. And then I'm going to provide the final tag -- greedy. So this is going to now evaluate this model on the human eval dataset. There you go. You can see we already got a post request here. We get one for every task completed. This is going to take quite some time. So again, I'm not going to run all of this here. But essentially, you go through the 164 examples here, step by step. These are Python coding examples. And in the end, we're going to get a score based on that. I'm not going to wait for the result to finish, but this is how you would run this benchmark. In the end, also you get a score. But then again, one of the most popular benchmarks, Terminal Bench, requires Harbor. So this is again a different approach. Terminal Bench here is used like this. So I want to cover that for the sake of completeness too. But instead of doing this again with vLLM, I also want to show you how to do this with Ollama. For this, all you need to do is you need to say Ollama serve once you have it installed to keep it running. You need to pull the model that you're interested in. So Ollama pull Quen, whatever the identifier is. In my case now here, if I do ollama list, you can see I have Quen 2.5 coder 0.5 billion. That would be the identifier. This is not pulling from Hugging Face, so you need to provide the ollama name. So ollama pull this model would be the correct command. In my case, I already have it. And if ollama is running, you can basically access this model. So you don't need to do a specific command for hosting this model. You just have ollama running and you have all these models available so you can target them. So what we're going to do here now is I'm going to say uv add harbor. So we're going to install this here. And with this harness, with this framework, we're now going to evaluate this coder model, this Quen 2.5 coder model on terminal bench. So I'm going to say uv run harbor run -d, and this is going to be then the data set again, the task. So terminal -bench / terminal -bench -2 -1. Then -age is going to be terminus 2. This is basically the agent implementation, and then we need to provide the model. So -m, and here we're going to wrap this in quotations. It's going to be ollama chat and then /Quen. Actually, let me copy this. Just Quen 2.5 coder 0.5 billion parameters. And then finally, we need to provide --ak. API underscore base is equal to HTTP, again, localhost port. Now we need to ollama port, so we don't need the 8000, but we need 11434, which is the default ollama port, in my case also tunneled here via NVIDIA Sync. And then finally -n1. This is going to run this now on the full terminal benchmark. This can take hours. We're not going to wait for this to finish, definitely not. But this is going to use ollama to go through the terminal benchmark with this particular model. But if we want to run this on only one task of the benchmark to keep this simple and to have it finish faster, we can go and run the almost same command, but I'm going to say -t instead of -d, so not the full data set, just one of the tasks. We're still going to target terminal bench, but the task is going to be filter JS from HTML. That's going to be one of the tasks that we have in this data set. I'm also going to remove the final flag here. So this would be running on only one single task. And there you go. After around 2 minutes, we get a reward of 0. It didn't really work. So the model failed basically to accomplish this task. And this is the result. And a similar result is what we would get if we were running this on the full benchmark, but it would just take very long. Now, finally, I want to show you how we can run our own custom benchmarks. I'm not going to focus too much on the creation here. This could be a separate tutorial. I want to focus on, let's say you have a custom benchmark. How do you run it using the LM evaluation harness? For this, we're going to go back to vLLM. So I'm going to run the command that we had before, which is this one here. So we're going to run Quen 2.5 coder 0.5 billion instruct again. This is now up and running on my desktop. What I'm going to do now is I'm going to create a directory own bench. And here I'm going to define my benchmark. Very simple. I'm going to just create a file called mybenchmark.jsonl. This is going to contain the examples, just 3 questions, multiple choice. What is 2 + 2? Capital of France, and also which is a mammal. And I have the answers and then also the index of the correct answer. That is going to be my evaluation set. In addition to that, also a mybenchmark.yaml file. Again, the focus here is not going to be on the benchmark creation. So I'm going to copy paste this. Basically just a very simple multiple choice accuracy benchmark. I'm just going to define this. So now we have these 2 files here, and actually I notice that we need to call this YAML with an A because otherwise it's not going to be recognized. So my benchmark YAML has to be YAML. And then we can basically just go and run the same command as before. So here back in history, we have the uv run lm eval run command with the Quen 2.5 coder model and the arc challenge. We're going to replace arc challenge by my_benchmark, and we're going to also say here --include _path, and we're going to include the current directory. And this is now evaluating my model on the custom benchmark. There you go. This was very quickly, and we get a 100% score because the benchmark is not really complicated. we evaluated this model on the custom benchmark. So this is how you can run benchmarks on your own system. Again, multiple use cases. Maybe you have your own fine-tuned models that you want to evaluate. Maybe you want to evaluate some niche models that are not commonly listed in benchmarks. Maybe you have your own benchmarks. Maybe you have your own reasons to do that. But knowing how to benchmark models on your own system is a skill to have nowadays, a very important skill to have, because you can then make up your own mind about models, especially local models that you can run on your system. So that's it for this video today. I hope you enjoyed it and I hope you learned something. If so, let me know by hitting a like button and leaving a comment in the comment section down below. Also, in case you're interested, on my website, you'll find a services tab and a tutoring tab. There you can contact me if you need help with a project, if you need a freelancer or a consultant. You will find links to my LinkedIn and my email at the bottom of both pages. Besides that, don't forget to subscribe to this channel and hit the notification bell to not miss a single future video for free. Other than that, thank you much for watching. See you in the next video and bye.